All right, class, today we are in section 2.5, and this should be a nice review from pre-algebra, and we're going to talk about the idea of distributive property. Now, just kind of wanted to review something with you here at the beginning. We use distributive property all the time to do mental math. And so let's take a couple minutes to prove that as we go through. If I told you that I wanted you to multiply 5 times 73, well, some of you would find that kind of hard to do if I expected you to do it with mental math. But there is a way that I can break this up to make it easier. Instead of 73, let's break it up into tens place and ones place. So let's make this 70 plus 3. Now, if I do it that way, then this is a little bit easier because 5 times 7, or 5 times 70 is 350, and then 5 times 3 is 15, and then that's pretty easy to add in my head and get 365. So again, mental math all the time in our head. Let's look at my second problem here. If I look at my second problem here, if I wanted you to multiply 8 times 9.5, I'm going to say, Mrs. Byrne, you want me to mentally multiply decimals in my head? Well, yeah, I do. But let's break it up, and let's make it into 2 smaller parts that would be easier to do. So let's make this 9 plus 0.5. So if I'm going to work it that way, now let's see what would happen. What's 8 times 9? Well, 8 times 9 is what? 72. And then 8 times 0.5. Yeah, 0.5 is half. So what's half of 8? And everybody's going to say 4. So that's pretty easy to do in my head. And I just get 76. All right. Let's look at my bottom mental math problem. I want you to multiply 6 times 2 1/3. You want me to do mental math with fractions? Yes. We can take this and we can break it up into 2 plus 1/3. And now we can multiply 6 by 2 and we would get 12. And what's 6 times 1/3? Well, that would give me 6 over 3, which is 2, and so it equals 14. So guys, like I said, we use our distributive property all the time doing mental math. Now, let's see what distributive property is. So here's my slide for the definition. Now, if you notice, there's two different aspects here. We've got distributive property of multiplication with respect to addition. So if you look here, it says for all real numbers A, B, and C, A, now do you notice what's in the middle? Plus. Okay, so that's why they call it with respect to addition. And again, we're going to see, hey, I'm going to take what's outside and multiply it by inside. So A times B, and then we multiply it by the second number, and we're going to get plus A plus C. Now, because it was addition, did you notice my plus sign went in there? It did. Now, let's look at the bottom one. Now, sometimes they try to be slick, and so they put the A behind the parentheses instead of the front. Do you think that's going to change what we do? No, it's not. So now we're going to say, okay, A times B, and then there's a plus sign in the middle, so we're going to plus sign over here, and A times C is AC. So we get the same answer whether the number is in front of the parenthesis or the number is behind the parenthesis. Now, let's look at the bottom, and we're going to see I can also use distributive property of multiplication with respect to, let's go with a different color, subtraction. Okay? All right, so let's look. What do you notice different between the top 2 equations and the bottom 2 equations? Yeah, it's just the sign in the middle. So if I look at my first problem here, they want me to take A times B, which is AB. Ooh, what sign's in the middle? Subtraction. So I'm going to put subtraction in mine. And then A times C. And once again, if you look at the bottom example, they're trying to be slick. They put the A behind instead of in front, but it's the same idea. A times B is AB. There's a subtraction sign in the middle, and then we've got AC. Okay, so let's kind of look at some things here and practice a little bit for today. Now, I got a real important question to ask you. If I look at the first problem here, it says, would you use the distributive property to simplify? Hey guys, would we use distributive property to take care of that first equation? Ooh, do you see my parentheses? What do parentheses mean? Yeah, do me first. Hey, can we do the math in the parentheses? Yeah, 23 plus 17 is what? 23, 33, 40. Okay, so that gives me 40. And then we know 9 times 4 is 36. And we'll just add a 0 on the back, 360. But now let's look at my bottom example. Would I need to use distributive property for that problem? Yes, I would. What's the game changer? What's extra in the blue arrowed problem that's not in the red? Yeah, we've got a variable in there. So that changes things. If there's a variable in there, there's no math I can do. I don't have like terms. I can't put them together. So therefore, I have to use distributive property. Okay, guys, everybody copy the blue problem on your paper, and let's see what we can do with it. Now, remember, we've got 9 on the outside, and we've got to multiply that by everybody on the inside. So what is 9 times 23? Oh, Miss Burton, I don't know. Well, no shame. Let's go over here and do the math. We got 23 times 9. Okay, 9 times 3 is 27. We'll carry our 2. 9 times 2 is 18, 19, 20. So we've got 207. What do we need to write beside there? X. Good job. Plus, now we need to do 9 times 17. Okay, here we go. 17 times 9. 9 times 7 is what? 63. And we've got 9 plus 6 is 153. Okay? No shame in doing your basic math over here to make sure you get the right numbers. Now, let's look at the green problem at the bottom. Oh, do you see what they did? They're trying to be slick. Okay? They put the 4 behind, but we're still going to take the number outside of the parenthesis, whether it's in front and back, multiply by everybody on the inside. So this is going to be 4 times 6m, which is what? 6 times 4 is 24m. What sign's in the middle? Minus, so I need a minus sign in mine. And now 4 times 7n, which is what? 28n. Now, question for you. Can I put those together? Good job. Remember, I can only put them together if they have the exact same variable. One is an m and one is an n, so it's a done deal. I am finished. I can't do anything else. Great job. Okay, now, let's look over here. Now, here comes the idea where I said we do a lot of this distributive property in our heads. To simplify an expression, to replace an expression containing variables by an equivalent expression with as few terms as possible. Now, it says simplifying the expression, but another thing that we say over and over again is collecting like terms. Okay, same idea. All right. So let's look at my first example here, and I've only got one. We can use the distributive property for, to show that 7x plus 5x equals 12. Now here's what I mean. If I look here, I've got 7x plus 5x, and hey, we say, hey, those are like terms. They're both an x. We actually just take the 7 and 5, and we do this middle step in our head. We say, hey, 7 plus 5 is 12. And so when I combine or simplify that, I get 12x. Okay? So you see what I mean by we do it in our heads all the time? All right, so distributive property, kind of like the inverse or the opposite of distributive property, is how we collect like terms. Once I realize I have the same variable, I pull out those coefficients, and I just do the math in my head. 7 plus 5 is 12x. Great job. Okay, we're going to practice a few, and let's see what we've got here. So let's go ahead and let's look at number 1. If I look at number 1, Okay, we're going to simplify the expression. I moved that down, but that's what my directions say. And we realize I've got distributive property. Now, we know, hey, parentheses, we got to do parentheses first because of PEMDAS. And so we would look up here and we'd say, okay, 8 times b is 8b. And then 8 times negative 5, or we've got a minus sign in the middle, so this is over subtraction. 8 times 5 is 40. Now, can I do anything else? No. The 4 has a b, and the 8 has a b, and the 40 doesn't, so we can't put them together. So that is my final answer. Let's try number 2. Once again, we've got a number outside the parentheses, so 7 times 5n is 35n, and 7 times 3 is 21, and there was a plus sign in the middle, so it was over addition. Now look at number 3. If you look at number 3, you notice we got some extra baggage here besides our distributive property. Well, I still need to take care of parentheses first because of PEMDAS, so this is going to be 11 plus 3 times 4 is 12. And then 3 times negative y is negative 3y. Now, do you see, have we simplified completely? Do you see some things we can put together? Yes, we can put our constant terms together, the 11 and the 12. 11 plus 12 is what? 23 minus 3y. And that's my final answer. Good job. Okay, let's everybody copy down number 4 in your notes. So if we copy down number 4 in our notes, they're trying to be slick. They put the 6 behind. Okay, so 6 times y is 6y. And 6 times negative 3 is negative 18. And we still got this plus 15 here on the end. Have we simplified completely? Nice call. Nice job. Did you notice we've got a negative 18 and a positive 15 we can put together? Yeah, so our final answer is 6y, and then different signs we're going to subtract, so we get minus 3. Nicely done. All right, guys, let's everybody copy down number 5, and let's try it. Ooh, distributive property times 2. No worries, we can take care of that. Everybody got it written on their paper? Good job. Here we go. So we've got to multiply 4 by everybody in the parentheses. So 4 times n is 4n, and 4 times 7 is 28. So distributive property number 1 is done. Plus, let's do distributive property number 2. This time we're going to take the 5, and 5 times n is 5n, and 5 times negative 3 is negative 15, and we've still got that minus 2n on the end. So now, have we simplified? No, we've still got n's and whole numbers. So, who can we put together? We can take 4n plus 5n, which gives me what? 9n. Nice job. And then we've got negative 2n. So 9n minus 2n is 7n. And then let's look at our numbers, our constant numbers. We got 28 and we've got negative 15. Same sign or different signs? Different, so we're going to subtract. Bigger numbers positive, so plus 13. And that's my final answer. Great job. Now I want you to really pay attention as you multiply tonight on your homework. Let's go ahead and get started.